Question 2. Figure 2.1 shows two rear-wheel trucks on a track. A truck of mass 6,000 kg is moving at 5 meters per second. It is approaching truck B of mass 5,000 kg, which is stationary. Okay, so from here we can extract information. So this is mass, let's say this is MB equal to 5,000 kg. Mass B, sorry, mass A. Mass A is 6,000 kilogram. And this is 5.0 meter per second is initial velocity. So VA, V stands for velocity, and then write I here. What is I? I is initial. I mean here before the collision. Okay. And then what else we have? This is stationary, so V equals 0, VB. VB equals 0 meter per second because it is stationary. This is VBI also, initial velocity is 0. Okay, calculate momentum of truck A. Okay, for this question, you need to calculate the momentum before the collision. Okay, so simply use formula for momentum. P equals mv. So here's the formula. Remember, VAI. I stand for initial before the collision. And then you get the answer, 30,000 kilogram meter per second. Once again, never forget to write the unit. Okay, 1 mark for the calculation and 1 mark for the answer with correct unit. The truck collide, their buffers compress, and then they bounce off each other, remaining undamaged. After the collision, truck B has a momentum of 27 kilogram meter per second. Determine the impulse applied to the truck. Okay, so this is the momentum after the momentum after collision. So initially the momentum is 0. Before the collision, remember the velocity is 0. So momentum of truck B before the collision is 0. Okay, but after the collision, it is 20,000 kilogram meter per second. So how do we know the change of momentum? From 0 to 27,000. Here is the change of momentum. Okay, from 0 to 27,000. So that is impulse. Impulse, because the formula for impulse is what? Ft equals mv minus mu. Okay, this is change of momentum, and this is impulse. Okay, so change of momentum is 20,000 given here because it changed from 0 to 27, so that is change of momentum. And change of momentum is equal to impulse. That's why impulse is equal to 27,000 kilogram meter per second. Understand or not? Okay, next question. The trucks are in contact for 0.60 second. Okay, since you know that they collide, okay, they collide and then it bounce, right? Both of them will move after the collision. So when they are in contact, we know that the time is only 0.60 second. So how do you calculate the force? This is also known as impulsive force. Okay, the impulsive force, the formula is mv minus mu over time. So this is 27,000 and this is 0. Remember, we are calculating for truck B. That is why we have initial momentum 0 because initially it is at rest. Then you calculate, you get 45,000 Newton. You must make sure you write correct unit because you are calculating force, so your answer must be in Newton. Understand? Okay, next. Calculate the final speed of the truck. Truck A. Okay, this is truck A. Okay, so we need to understand something here. Let's go back to this diagram. So initially, while this truck is moving, okay, we know this is the momentum, right? 30,000 kg per second. So when it collides, okay, so when it collides with this truck B, okay, initially this is 30,000, and then when it collides with truck B, now after the collision, truck B has 27,000 kg per second momentum. Okay, this is before momentum. So is there any difference? 30,000 and 27. You can see the difference, right? The difference is 3,000. So this 30,000, from because we have learned about conservation of momentum. The momentum before and after collision should be the same, but you can see here it's not the same. So 27,000 has been gained by truck B. So we have only remaining 3,000 kilogram meter per second momentum for truck A. So the remaining momentum for truck A is only 3,000. So that is why you can see here, after collision, okay, remember I use F. F stands for final. So final momentum for truck A is this formula, P equal mv.